We're going to start talking about exponential functions. First of all, this is what an exponential function looks like. F of x equals a to the x. A is always positive. A is never equal to 1. And x is any real number. Okay, if I look at two different graphs, I've graphed f of x equals 3 to the x and f of x equals 5 to the x. So two different exponential functions. And we're going to look at what their table of values looks like from -2 to +3. So if I put in 3 to the -2 power, I get, okay, so 3 to the -2. If I fix my negative exponents, that's 1 over 3 squared, so that's 1/9. 3 to the -1 would be 1 over 3, so 1/9 to 1/3. 3 to the 0 is anything to the 0 power always equals 1. 3 to the first power equals 3. 3 to the second power 9. And 3 cubed is 27. So what I want you to see here is as my numbers are getting larger, they're getting large very fast, thus increasing exponentially. But when my numbers are getting smaller, going up this way, it's the denominator that's changing. It's going to be 1/3, 1/9, 1/27, and so on. It's not actually ever going to get to 0. That fraction is going to be getting closer and closer to 0. So what happens is I have a horizontal asymptote here on my exponential function that essentially it's not crossing the horizontal axis. And I can do the same thing for 5 to the x. That's going to be 5 to the -2, so 1 over 25. 5 to the -1, 1/5. 5 to the 0 is 1. 5 to the first is 5. 5 squared is 25. And 5 cubed is 125. So again, getting exponentially bigger this way and getting closer to 0 this way. So on these, I would have a horizontal asymptote at y equals 0. I don't have an asymptote, a vertical asymptote over here, because my x is going to keep getting bigger and bigger and bigger and bigger. Now what happens to two graphs if I have negative exponents? Well, essentially it just flipped my graph over. And if I look at the values that come out of that, 3 to the -x for x equals -2 would be 3 to the +2, which would be 9. 3 to the -1 would be 3. 3 to the 0 is always 1. And that's one thing you'll notice. You will always, at x equals 0, you'll always cross at 1 right there. Now 3 to the -1, now I've got 1/3. 3 to the -2, 1/9. 3 to the -3, 1/27. So now it's kind of in the opposite direction. As my x's are getting smaller, my y value is exponentially increasing. As my x values are increasing, my y values are decreasing, going towards 0. For 5 to the -x, I'm going to have 5 squared, which is 25. 5 to the 1, 5. 5 to the 0, 1. Now 5 to the -1 is 1/5. 5 to the -2 is 1/25. 5 to the -3, 1/125. Same thing going on here. This is going to 0, while this is increasing very fast to infinity. So even with my negative exponent, I still have a horizontal asymptote at y equals 0. The other thing that increases exponentially is interest. When you put money into a savings account, you earn interest on it. This is the formula you're going to use for compounding. Anytime you start with a principal of p, you multiply by 1 plus r, whatever your rate is, in a decimal form. N is the number of times it's compounded per year, and T is the number of years that money stays in the account. If your account is continuously compounding, it's very rare. This is the other formula you use. It's rare to ever find this in real life, but it is good in case you're looking for a maximum. What's the maximum I can earn in this account, no matter what account I put it in? Okay, given this problem, we were investing $4,000. That's going to be my P. Annual interest rate, so my R, 0.0525. Find the balance in the account, that's A. Compounded monthly, so my N is 12, so it's 12 times a year, and 6 years would be my T. So A equals 4,000, 1 plus 0.0525 over 12 to the 12 times 6. Plug all that in. I get $5,477.27. Don't ever round that number up. In a bank, they're not going to give you more money for rounding for anything. You always just truncate it after 2 places. So in this problem, I grew my money from $4,000 to almost $5,500 over the period of 6 years. Okay, let's say when you're born, you are starting out with a trust fund of $25,000. So there's our principal. Here's your interest amount, so your rate is going to be 0.0825. Determine the balance, which is your A, on the child's 26th birthday. There's your T. If the interest is compounded, let's try quarterly. Okay, so that's going to be my principal. Oops, another 0. 1 plus 0.0825 over quarterly would be 4 times a year over 4 times 26. And my account would now be $208,941.65. Now let's do it if I was compounding monthly. Let's see, I'm still going to start with 25,000. 1 plus, my interest rate has stayed the same. Monthly would be 12 times a month. And in this account, I would make $211,989.34. And one more time, let's compound continuously. Be my principal. E is in your calculator to the RT. R would be 0.0825 times 26. And in this account, I would have $213,551.03. So obviously, continuously would be the best. Like I said, that's rare. The more times you can compound per year, the better.